Are you normal? Most processes are normally distributed. They have the shape of a bell curve. Sigma is a measure of variation around the average. In-control processes are predictable. All organizations should have two process improvement goals: reduce variation and shift the average towards the desired level of performance. Don't hammer people for common cause variation, but do expect variation to tighten over time. When a system is normally distributed, certain percentages of its values fall within certain distances from the average. Well-designed processes have less variation and are more predictable. With all processes, half the time you spend will be above average, and half the time you spend will be below average. The question is, how much above or below average will you be? Understanding variation helps us to predict future process performance. Process variation is measured by looking at the standard deviation, also known as sigma, of a given measure. In normally distributed systems, 99 to 100% of the values produced by a process will fall within a process width of 6 standard deviations, 3 on one side of the average and 3 on the other. Completing a control chart for a given process metric helps you learn more about the relationships that exist between process width, variation in other words, and process predictability. A key role of management is being able to predict what a work system will do. Once a supervisor or manager can predict what their systems will do, they will also have a better idea of what their systems are capable of, and that helps them make better decisions. As fundamental work system changes are made to improve systems or processes, the control charts for the affected measures should reflect the success of those changes. In particular, variation, or process width, should decrease. One common area of failure occurs when customer specifications don't match up with what the process is capable of providing. For example, if an emergency room promises to treat all patients within 45 minutes after they arrive at the hospital, the value of 45 minutes should be 3 standard deviations lower than the process average. If it's not, customer expectations will not be met a certain percentage of the time. Similarly, if sales promises the customers that a part will have a tolerance of plus or minus 1 inch, the process width of the system should be no wider than this amount. Most people don't know what their systems are capable of providing because they haven't done the measurement and charting. Instead, they make promises to get business and hope that others will find a way to meet the expectations of these new customers and in turn keep them. Understanding variation. Every process has variation. We want to see some variation. If things appear the same, we aren't close enough to see the difference. Tolerable amount depends on customer or product impact. Excess variation wastes time and money. W. Edwards Deming said, "If I had to reduce my message for management to just a few words, I'd say that it all had to do with reducing variation." If we understand a system, we can predict within a range of values how it will perform. This range of performance is known as variation, the difference between the lowest and highest values for a majority of the results produced by a process when it is measured. All processes have some degree of variation, but this amount can be large or small. Sigma, or standard deviation, is used to measure variation, the width of a process. Some process parameters may vary significantly from day to day, while others may consistently fall within a tight set of values. Whenever variation is high, it is more difficult to provide a consistent product or service. In other cases, we come to depend on the consistent results that tightly controlled processes provide us. Which of your work processes are the most predictable? For example, consider the school bus that takes a child from their home to school each day. If we time the length of this trip daily, we could calculate the average time to make a trip. Most of us know how to do that. What fewer of us recognize is that we could also predict the percent of time the bus would be within 2, 5, or 10 minutes of the average. Understanding the variation in this child delivery system would allow us to make this type of prediction. Most systems exhibit behavior that is distributed normally. The curve on the previous page shows a typical and stable normal distribution. There are some systems that follow a different distribution, such as exponential, but most are normal. You can use a check sheet and then a histogram to explore the variation for each process vital sign that you monitor and each outcome your processes produce. Some people get hung up on special versus common cause variation. According to Shewhart, who Deming learned from, special cause variation only occurs 1 out of 100 times or less. If your process control chart is showing a higher rate of special cause variation than this, odds are your control limits are not based on data that is reflective of the current process you are charting. It's much more common to see processes that are much too wide. Too much variation. The control limits are too far apart.